For lesson 7.2 in our Algebra 2 class, today we're going to really simplify radicals, not just square roots, but also cube roots, fourth roots. A quick note that I want to start this lesson with is, in all honesty, we can even work from the right side to the left as well as either direction. But if you have the nth root of a times the nth root of b, that would be equivalent to the nth root of a times b. And like I said, you could move from the left side to the right side just as well. Generally, with the quotient property, if you have the nth root of a over b, that would be equivalent to the nth root of a divided by the nth root of b. But ironically, very often you'll see in a moment, we'll usually start with something like the right side and move to the left. Well, that being said, let's just revisit a problem that we've done in Chapter 5, simplifying a square root. Now, a square root is an index of 2, and that's going to indicate that to get any simplification, to remove terms from a radical, we need to have two items that are exactly the same. So let's do a little division tree, or a factor tree if you would, with 18. Try your first prime number, 2. 18 divided by 2 is 9. 2 obviously can't go into 9, but your next prime number, 3, does. And you can see very quickly this is 2 times 3 times 3. So breaking 18 down into this form, we ask ourselves, well, looking at our index, do we have 2 of the same number anywhere? And we do. And whenever you circle the same number of items, 2 items here, you can pull one of them out, cross out the rest, and we would be left with 3 times the square root of 2. Let's jump over to example 3 before we do example 2, though, because this is very different. This is a third root. We should break 16 down with a division tree. 2 goes into 16 8 times, 2 goes into 8 4 times, and 2 goes into 4 2 times. So you can see very nicely our prime factorization. 16 is 2 times 2 times 2 times 2, 4 2's all in a row. But very importantly, when we are dealing with cube roots, we're no longer looking for 2 of the same factor. We're looking for 3 of the same number, or 3 of the same variable. Very same principle that we just saw. You can say, I'm going to take one of those factors out, forget about the rest. Please watch out, though. The big mistake that kids make initially is they want to turn this radical back into a square root, like we had for number 1. This is still a third root, a cube root. As we look at number 2, you might notice this is pretty much how we started the lesson off. If you have 2 radicals multiplied together, you may join them together as 1. But that being said, 3 is already down to its prime factorization. 9 is really 3 times 3. So rewriting these radicals in their factored form, prime factored form, I can now say let's join these 2 radicals together. That's what we started the lesson off with right up here, saying when you're multiplying 2 radicals, you may make them 1, multiplying those 2 quantities together on the inside. And now we really have our cube root, and we can say, well, do we have 3 of the same number, or 3 of the same variable? And we do. I can very simply take one of those out. You might notice there's nothing remaining, meaning there's no need to write a radical anymore. There is no more radical. The answer, plain and simply, is a 3. As we continue, you can see we've got the fourth root of 48 all over the fourth root of 3. Just like we had at the top page, we can join the 2 radicals into 1. Again, you might look at this and think, well, how is that helpful? Well, actually, 48 is divisible by 3. So this problem becomes the fourth root of, well, 48 divided by 3 is 16. Now, we just did the factorization of 16 a moment ago, and for example 3. And we saw in that problem, you can look back to number 3, or you can refer back up here to this division tree. We'll have 4 2's multiplied in a row. And we're looking for 4 of the same number. Well, you get 4 2's right here. What you're going to see is that now I can take a 2 out. There's nothing left, so there's no need to write a radical any longer. For number 5 and for number 6, this is noticeably different. What I want to point out is the obvious statement that now we have variables instead of having to break down numbers in their factored form. In their own way, they're very much the same problem. You have a second root, a square root. I'm going to have 4 x's all multiplied in a row. That's what x to the 4th really is. I'm going to have 3 y's, and then I will have 5 z's. And now we're going to go on a search for 2 of the same item. Wherever I have a group of 2, I'm going to circle that. And what that's really meaning is an x can come out from this first group, another x can come out, by the way that's going to get multiplied, a y can come out, a z can come out, another z can come out, and then what's left? Inside the square root, I'm just left with a y and a z. But look, x times x is actually x squared. And this is really x squared. A z times z is a z squared. And then we're left with yz inside that root. Now, please understand, whenever you've got it in the beginning, revisiting here, I think many students will say, well, my goodness, I know that I've circled an x pair and another x pair. Can't I just now realize taking out 2 x's multiplying together is x squared? Of course you could do that, and that would be the smart way to do it. All right, so let's take a look at example 6. Very, very similar kind of a setup, except now we have a third root. So I've got 4 a's multiplied together. I'm going to have 5 b's and a singleton c. And, you know, the third root, we pay so much attention to that. That's indicating, hey, look for 3 of the same term. And we've made a couple of circled forms here. So I can pull out an A, pull out a B. Don't forget, this is a third root. It's always going to be a cube root here. You need to write that 3 in. What's not circled? Well, we've got an A, and a B multiplied to b squared, and then we have a C. And that's going to be our final answer here. All right. Well, exponent review is we're looking at, you know, really what we did in chapter 6. X to the A times x to the B, well, that's really x to the A plus B. For number 2, a power to a power, raising a power to a power, we multiply the 2 powers together. That's x to the A times B. X to the negative A, well, that's really 1 over x to the A. And here we have x to the A divided by x to the B. That becomes x to the A minus B. So very quickly, what we can do here is hopefully notice for example 7, we're not doing all these for the sake of time, but example 7 I hope looks a lot like number 1. We can take 1/6 plus 1/3. And 1/6 plus 1/3, you could let your calculator add those two together if you're struggling with fractions. You know, no doubt about that, it makes life pretty easy, especially with this nice fraction form. Many of you will find it to be quite quicker to add this together just by hand. But if you've struggled with fractions in the past, you can see that actually works out to a half. Now what you should always do is quickly see if we can work out 9 to the 1/2. So I'm going to raise 9, hit that caret button, bring back that fraction, and type in 1 all over 2. Hopefully you remember from the first lesson this is really the square root of 9. Final answer that we should write down is simply 3. For number 8, I hope you look at that problem and more or less see that it's property number 4. We will subtract our exponents. 5/8 minus 3/8. Well, that would be 2/8. And 2/8 actually reduces to 1/4. Now again, you might remember from our first lesson, this is really equivalent to the 4th root of 81. And if we need to, we could break that down by hand. But listen, why not double check and see if this works out evenly? So very often it does. And here you can see the 4th root of 81 is actually a 3. On the other side, like I said, we're just going to do a few more of these. What you've got here is really some review. 25, is really 5 times 5. This is a second root. You've got y to the 4th. Well, that's 4 y's all in a row. I've got a group of 2, a group of 2, and another group of 2. Out comes a 5, out comes a y, out comes a y. There's nothing left. Final answer is 5y squared. As we look at number 14, let's take a look at 14. We're going to apply a 1/3 power everywhere. This is 8 to the 1/3. Powers raised to powers, we're going to multiply that together. So it's 3 times 1/3. This is 9 times 1/3. And once again, we could real quickly type in 8, raise it up to that 1/3 power. That, by the way, is the cube root of 8, which hopefully you know should be a 2. Hit enter and you'd get a 2. 3 times 1/3, well, either with the calculator or just canceling there, you get u to the first. Use a calculator or work this out by hand. 9 times 1/3, 3 goes into 9 3 times. 3 times 1 is just a 3. Hey, look at that. Just want to finish up with 15 and 16. These are like term problems. Really, I have a 3 cube root of x plus 1 cube root of x. This will become 4 cube root of x. Last one, 8 fifth root of x plus 4 fifth root of x. 8 plus 4 is 12. We'll be left with 12 times the 5th root of x. So really, that's all we've got.